Hello, this is Similar Figures with Mr. Anderson. We are doing similar triangles more specifically. Technically, there are other shapes that are similar, but this worksheet is specifically for triangles. Or at least these notes. This worksheet is technically for anything, but I only have examples of the triangles because it's in my triangles unit. So, first of all, similar. There is a symbol that we will be using for similar. It is called a tilde, or more commonly known, that little squiggly thing on your keyboard that it looks really funny. It's called a tilde, and that is the symbol we use for similar. So you will be seeing that. It is called a tilde. That is that. And it means similar. It is a symbol, just like this is an equal symbol right there. Just like this is the congruent symbol right there. Which, it's kind of funny. The equal sign along with the similar sign together make the congruent sign, which looks funky. So there it is again. I don't know if you remember the congruent symbol, but that's what it is. An equal sign with a similar sign together make a congruent sign. But here we go. Figures that have the same angles, but not the same size, are considered similar. So if you have a small object and you were to just make it bigger, it would be a similar. It has to be the same size, the same shape, but you can make it bigger. The way I think about it, unfortunately I can't have a computer down here and showing you, but for any of you who have ever copied a picture and pasted it somewhere on your computer, you have that box. Let me zoom out a little bit. They give you a box and the picture's in that box, and you have a total of 8 options. Either right here there's a little box, there's a box right here, there's a box right here, a box right here, and then there's the 4 on the corners. Now, as you may know, if you've done this, if you take the box down here or up here or one of the ones on the sides and you click on it and drag it, it distorts the picture. You can make it really tall so it stretches, you can make it wider than it's supposed to be and it stretches. But if you pick one of the ones at the corner, it keeps things in the same shape. It just makes the whole image bigger or smaller, like that. But it keeps it with similar figures. The picture looks the same, it's just you're changing the dimensions to be bigger or smaller. And that is the exact same thing of similar figures, similar triangles. These triangles look exactly the same, except for one is smaller, and that's it. Or you could say they're exactly the same, except this one's bigger, but that's it. They're still the same shape, and they would still have the same angles. I don't know if I can do a simple proving it to you, but let's just say I have this angle right here I'm going under. Right there. I have just copied this angle right here, and you will see that it is the same angle as that one over there. It has to be, right? You can probably just eyeball to see that they look the same, but it is the fact that that angle is going to match that angle right there every single time. And if I was to do this angle, that's about 90 degrees. You can see that that one's also the same. So it's not just me blowing smoke here. It is actually having to be that way. The angles will all be the same. So corresponding angles are congruent or equal. I'll just put congruent or the same. Meanwhile, the corresponding sides are proportional. If you don't know what proportional means, then I suggest watching the other video I made on proportions. That'll be very helpful. It'll be very helpful for this notes if you watch the proportional video I made. So here we go. So corresponding angles. Angle A is 40 degrees, apparently. So the other one that's 40 degrees is angle D. So that means A and D have to be congruent, or they are congruent. And they are called corresponding because all 3 angles are the same, and as I'll show you, all 3 sides are proportional. With B is up here in 60, E is up here in 60. So B and E are congruent. So then the only thing that's left is C, which is 80, and F, which is 80. like so. Corresponding sides. Here it has AB, and this is AB. And this is DE, so this is DE. And you can see they're both in the same location. These are oriented the same way. Like this one is not, they're like tilted-ish, but these ones are exactly oriented. So the one on the left, it's saying they're corresponding. 4 is going to 8. So the way you write that is 4 over 8. 4, 8. So 4 over 8, it's a fraction. The next one it says is BC. So here's B and here's C, so here's BC. The one on the right. So you could tell that this one is also going to be the one it corresponds to. 6, 12. 6 over 12. So then the only thing left is this side right here, the 8 and the 16. 8 and 16. And what do you notice about all three of these numbers? If you want to pause, you can. The answer is they all simplify to exactly 1/2. Right? 8 is half of 16. 6 is half of 12. So all of these things are equal, and that is what it means to be in proportion, or they're proportional. There you go. The scale factor here would just be, since our fraction was 1 over 2, the scale factor would be 1 to 2. Like that. You could technically also write like 4 to 8. Scale factors don't have to be simplified, it's just that they usually are. So you could do 4 to 8, or 8 to 16, or 6 to 12, but they're all the same. So usually you just write it simplified, but you don't have to. Let's see, I didn't actually write these in. BC would be EF, and AC would be DF. So yeah, you can see AB goes to DE as BC goes to EF. Just like that. Done. Okay. For some actual problems, it says the triangles are similar, find the value of x. We're setting up proportions. It says that the angles have to be equal and the sides have to be proportional. Well, it doesn't label any angles, so we don't have to care about that. We do have to make sure that the sides are proportional. So here we go. 6 is matching up with 18. 6 is matching up with 18. So then 8 is matching up with x plus 4. 8 is matching up with x plus 4. And if you just watched my other video, then this should look very familiar. If not, then you should pause and go watch it like I asked you to. But you would put this in parentheses and you would cross multiply. So 6 times x plus 4 and 18 times 8. So you get 18 times 8, oh boy, let's see what that is. I don't know off the top of my head, so I'm just going to do this. Oops, that's a 4. 64, 8 plus 6 is 14, 144. Huh, that's interesting, cool. So 144 is equal to 6 times x plus 4. Excuse me, oof. So then you would distribute this to get 6x plus 24. Okay, after that, subtract 24, and you get 120. And divide by 6, you get x equals 20. Ching ching. Done. So here, it says given the scale factor from A to B is 4 to 10, so start out with 4 over 10, right? A to B So a to b is 4 to 10, right? A to b is 4 over 10. Find the missing side. So that would be 2 to x. That's what it is. 4 to 10 is 2 to x. So this part doesn't really matter. I was just using it to, organize, to remind myself that everything A goes on top and everything B goes on bottom. So it says A is 4 and 2. So A was 4 and 2. And then B was 10 and x. But after that, you will just once again cross multiply to get 4x equals 20. Like so. That's after this. With that said, we are now going to be doing something called proving. Triangles are similar, but I think I've talked enough for one video, so I'll catch up with that on the next one. Take care.